Hey everyone, welcome back. In this video, I'm going to walk you through the essential Linux skills you need to build, train, and deploy artificial intelligence and machine learning models. You know why this matters? Because most modern ML infrastructure runs on Linux, and if you cannot navigate the terminal, manage environment isolation, or debug hardware-level driver issues, you are effectively locked out of production-grade AI development. This is more critical than you think, as one misconfigured library path can derail a week-long model training job. This is the definitive guide to the Linux competencies that separate hobbyists from professional AI engineers. Let us get into it. In this video, we will cover the critical Linux file system skills for handling massive datasets, how to monitor your training jobs so they do not crash, and the art of environment isolation to keep your dependencies clean. We will also dive into the technical details of managing NVIDIA drivers and automating your data pipelines with shell scripts. Specifically, that includes navigating Linux permissions, process monitoring, environment management, hardware driver troubleshooting, and automation. Watch the full video without skipping any content to understand it better. Before we get into the topic, a small request to you. I have already uploaded many technical videos on different technologies and tools. We share more knowledgeable content every day, so if you're interested in learning and want to improve your skills, make sure you have subscribed to our channel and joined our WhatsApp community. The join link is available in the description or scan the QR code shown on the screen. Let us get started. So what is the actual problem here? Most AI developers start in a Jupyter notebook on a local laptop. That works fine until you need to train a model on a multi-GPU server in the cloud. Suddenly, you are facing permission errors, missing CUDA libraries, or disk space issues that the notebook environment just hides from you. If you do not have a solid grasp of how Linux manages resources, you will spend your time fighting the operating system instead of tuning your neural networks. It is a massive productivity killer. Now, what is Linux in the context of AI and machine learning? It is the foundation for almost every major framework like PyTorch or TensorFlow. Linux provides the kernel-level control required for high-speed data processing and direct communication with hardware, like NVIDIA GPUs. Think of it like the engine room of a massive cargo ship. You do not see it while you're relaxing on the deck, but without that engine room functioning perfectly, the ship is not going anywhere. Understanding Linux means you are the engineer capable of fixing that engine. Before you dive into these skills, make sure you have the right setup. We assume you are using Ubuntu 22.04 LTS, which is the industry standard for most AI research labs. You will need sudo access to install system-wide dependencies. You should also have your NVIDIA drivers and the CUDA toolkit already installed, as we will be focusing on managing them. Open your terminal. If you're on Windows, use the Windows subsystem for Linux, or if you're on Mac, keep in mind that you will eventually need a Linux environment for deployment. Let us get moving. One of the first things you must learn is how to track hardware usage. When you are training a model, you need to know if your GPU is actually being utilized. On line 1, we use the watch command with the N flag set to 1 to refresh the nvidia-smi utility every second. This command shows you the GPU temperature, memory usage, and the specific processes consuming your VRAM. It is the single most important command for any AI engineer running experiments. Here is exactly what you should see. Notice the GPU utilization hitting 98%. This tells you your model is successfully saturating the hardware. If you see 0% utilization, your data pipeline is likely the bottleneck. That is exactly the kind of insight you need to optimize your training time. Now, let us talk about environment isolation. Never install AI packages globally. On line 1, we create a new environment named iProject using Conda, which is the preferred tool for managing data science dependencies. Line 2 activates that environment so all subsequent installs are contained. Line 3 installs PyTorch. By keeping your environment separate, you prevent version conflicts between different projects. This is essential when one project requires PyTorch 1.13 and another requires PyTorch 2.1. After running these, your terminal prompt will show the name of your environment in parentheses. This confirms that any Python or pip command you run is restricted to this specific folder. It keeps your system clean and reproducible. For production AI, you will rarely run scripts manually. You need automation. Here is a simple bash script. On line 3 and 4, we define our input and output directories. Lines 6 to 9 use a for loop to iterate through every CSV file in the raw directory and process it using a Python script. By automating this, you can walk away from your desk while your server prepares gigabytes of data for training. It is the foundation of a robust ML pipeline. When you run this script, it will systematically process each file one by one. This is much safer than trying to load all files into memory at once. It keeps your memory footprint low and your training data organized. And that is the key point. Let me share a real-world scenario. A medical imaging startup managing 50 terabytes of patient scans was struggling to train their diagnostic models. Their Python preprocessing scripts kept crashing because they tried to load too much into RAM at once. By switching to a Linux-based bash pipeline that processed files in small, manageable chunks and using the htop command to monitor memory usage in real time, they reduced training failures by 95%. This is why these Linux skills are not just theory, they are the difference between a stalled project and a successful deployment. Here is a classic mistake. You try to run your training script, but you get a permission denied error. This happens because the model output directory is owned by the root user, not your current user account. You might be tempted to run everything with sudo, but that is a security risk. The fix is simple. Use the chown command to change ownership of the directory to your own user account. By using the $USER variable, the command automatically detects who you are and assigns the directory to you. This is the professional way to handle permissions without compromising your system security. So when should you use these Linux skills? Use Linux for your core model training, deploying your APIs, and managing server clusters. It is the only place you will get the granular hardware control you need for GPU acceleration. Do not use Linux if your entire organization is locked into a Windows-only proprietary stack, as the overhead of managing a Linux server might be too high. Also, avoid it for simple low-traffic dashboards that you can easily host on managed serverless cloud services. Know your constraints. Use these criteria to decide if this tool is right for your situation. You now know how to monitor GPU hardware using the watch command and nvidia-smi. Remember to always isolate your dependencies with Conda to avoid version hell. Use bash scripts to automate your data ingestion, as this is how you scale from 10 files to 10,000. Always fix permission issues with chown rather than relying on sudo. Finally, master hop so you can spot memory leaks before your training job crashes. These 5 habits will make you a significantly more effective AI engineer. I believe this video will definitely be a useful video. If you like the video, please do like and hype the video. Also share it with your friends and groups. It may be useful to somebody else. If you have any doubts or any requests, please let me know in the comments. Make sure you have subscribed to stay updated for our regular videos. Join our WhatsApp community using the link in the description because we share more knowledgeable content every day. Thank you for watching. See you soon in the next video.